Hi guys, Miss Powell again. Today we're going to talk about the volumes of pyramids and cones. This figure that you're looking at is a pyramid. We can find the volume of a pyramid by using the following formula. V is equal to 1/3 big B times H, where big B is equal to the area of the base, H is the perpendicular height of the pyramid. The figure that you see directly below is a cone. We can find the volume of a cone by using the exact same formula, V equals 1/3 big B times H. Be mindful, though, that the base of a cone is a circle. Therefore, you could use the formula V equals 1/3 pi r squared times H, because, of course, pi r squared is, in fact, the area of a circle. Also be mindful that H, the height, is always a perpendicular distance. It is not a slant. It is always perpendicular between the vertex or the top of the pyramid or cone and the base. All right, so let's look at example number 1. With example number 1, you are asked to find the volume of each pyramid. Round to the nearest tenth if necessary. Since examples number 1 and 2 are very similar, I'm just going to focus on doing example number 1 right now. Just like lesson 6.1, the first thing that we want to do is we want to consider the area of our base. The area of our base is going to be 5 times 3, which gives us 15 units, squared of course. Our volume is equal to 1/3 the area of the base, which is 15, times the perpendicular height, which is 7. Multiplying these together, what we end up seeing is that our volume is 35 inches cubed because we are dealing in volume. All right, let's take a look at number 3. With example number 3, we're asked to find the volume of each cone. We want to give our answers both in terms of pi and rounded to the nearest tenth. So once again, first thing we want to do is find the area of our base. The area of our base is pi r squared, which gives us 16 pi, obviously feet squared. To calculate the volume, we take V is equal to 1/3 the area of our base, which is 16 pi, times the perpendicular height of our cone, which is 12. In terms of pi, this yields 64 pi feet cubed. Rounded to the nearest tenth, we get 201.1 feet cubed. Please be mindful, number 4 is done exactly like number 3 because it's tilted on its side, makes no difference whatsoever. So we're going to move on and look at examples number 5 and 6. We did examples similar to this in lesson 6.1. We were asked to describe the effect of each change on the volume of the given figure. So if the dimensions of this particular figure are in fact doubled, and I'm dealing with volume, I can take 2 and raise it to the 3rd power, and that gives me the number 8. Therefore, the effects of each change on the volume of the given figure is that the new figure will be 8 times as large as the original. Or the new figure will be 8 times larger than the original, I guess is a shorter way that you could say it. Looking at number 6, if we multiply the radius and the height by 1/3, we're going to follow the same logic, and we're going to take 1/3 and cube it. Don't forget your basic fundamental algebraic properties, right? 1 cubed over 3 cubed leaves us with 1 over 27. Therefore, what I can say about this is that the new figure will be 1/27th as large as the original. All right, moving on. Looking at numbers 7 and 8. It says find the volume of each composite figure, round to the nearest tenth if necessary. Once again, like in lesson 6.1, we want to consider what types of figures that we're looking at. The first thing that I would do here would be to calculate the volume of the rectangular prism that I have here on the bottom. So the volume of the rectangular prism is going to be big B times H. So 6 times 3 is the area of our base times our height, which is 5. Multiplying all of these together, what I end up getting is 90 centimeters cubed. Step number 2, you want to consider the volume of the pyramid. So considering the volume of the pyramid, I know that that's V equals 1/3 the area of the base. So what is the base on this pyramid? Well, the base is a rectangle. Okay, so I've colored it in here for you. Therefore, the area of the base is going to be 6 times 3 times the perpendicular height of our figure, which is 6. Therefore, once you multiply all of these together, you end up seeing that the volume is equal to 36 centimeters cubed. Finally, our last step here is going to be to add both of these together. So our total volume is going to equal 90 plus 36 centimeters cubed, which is 126 centimeters cubed. Example number 8 is done very similarly to number 7. However, what you want to consider is you have two separate cones here, right, that have been joined together. So if I was you, what I would do would be to figure out the volume of one cone, then figure out the volume of the other cone, and then add them together to get your total volume. I hope that you guys have a great day, and we will see you for lesson 6-3.